Shamila, why don't you start by uploading the first speaker, who is Akshita Rana. Her supervisors are Christoph Hagemeyer, Bieri Niego, and Eric Westeen. The title of her presentation is, it's changed. Dear Smart Little Antibody, may the force be with you. So very clever. And I believe Akshita, we're going to be presenting her recorded presentation. So hopefully this doesn't go for longer than 3 minutes.
This is Homer. He's famously known to drool at the sight of burgers, pork chops, pancakes, hot dogs, and everything greasy, cheesy, and sweet. A multiple-time winner of local beer drinking contest, Homer hates any kind of workout that requires excessive movement or even breaking a sweat for that matter. Except one exercise that he's particularly good at, the donut curl. And not surprisingly at all, Homer's unaware of a sneaky, sticky, fatty yellow deposit, or plaque as we call it, blocking his arteries, that's been growing over the years along with his belly. This blockage may even result in a major heart attack sometime soon. The story of Homer Simpson is sadly the story of millions of people worldwide, making cardiovascular diseases the leading cause of morbidity and deaths worldwide. To fight this global health concern, of course we have plenty of blood thinners in the market that prevent life-threatening blood clots. That's exactly what we want, right? Well, not really. As you see, just like any good movie, there's always a catch. These drugs not just stop the dangerous clots, aka the villains, but also the clots necessary for body's natural wound healing process, aka the heroes. And as a result, excessive bleeding occurs that may even prove fatal at times. Now, wouldn't it be great if there was just a magic pill that could save the day by smashing the villains, but sparing the much-needed heroes? You know, we might have just created one. We in our lab have developed a little CCS antibody, which is nothing but a protein, right? And it is smart enough to only prevent clots at the artery blockage sites without even touching the clots elsewhere. Now, how does it work, you might be wondering? Well, picture this. An artery is just like your garden hose, right? You restrict one end of the hose and whoosh, water comes gushing out with much greater force, and this is exactly what happens to the blood in an artery. Our antibody smartly senses the sudden increase in this force and voila, it jumps into action. You see? No antibody, huge clots, and Homer goes, "Doh!" Antibody, no major clots, and Homer goes, "Woohoo!" Now I know, there's still a long way before this antibody is ready for clinics, but with the promising results so far, it may well prove to be the much-sought answer to the global problem of cardiovascular diseases. And it may sound right, but until then, may the force be with our little guy. Thank you.
So the next speaker is Marissa Sergo. She's supervised by Rochelle, Glenn, and Reese. So her topic, or the title, is the role of the gut microbiome in recovery from adolescent repeated mild traumatic brain injury. Your time starts now.
There are more bacteria in our gut than stars in the galaxy, and like the delicate balance that is required for life on Earth to exist, so does our gut bacteria require for us to be happy and healthy humans. When living in harmony, this vast ecosystem nourishes our body from the inside out and plays an important role in keeping our brain functioning at its absolute best. In fact, recently it's been discovered that our gut bacteria can talk to our brain in order to help it to develop during the sensitive period of adolescence. Our gut bacteria wear many hats and are always on their daily grind, producing essential molecules to keep our immune system in check and keep the gates between our intestinal cells strong to make sure that there aren't any toxins getting out into our bloodstream. When this delicate balance of gut bacteria is thrown off, however, everything gets thrown off with it. The gut essentially hangs up the phone, and the communication between the gut and the brain is like that of talking to someone on the phone while traveling through a tunnel. You can have spots of clear communication, but the rest is just static, with you saying, "Can you hear me?" a million times with no answer. Those gates keeping our intestinal cells together are flung open, and everything that should be staying in the gut leaks out, creating inflammation in the brain, disrupting its functioning. Since we know that this delicate balance is necessary for brain development and keeping the balance of our immune system, could our gut bacteria potentially play a role in recovery from injuries that cause inflammation in the brain, like concussion? Could these tiny organisms really make a big impact? Well, that's what we're trying to figure out. My PhD aims to understand whether the bacteria in our gut are involved in recovery from concussion. In doing so, we'll be able to identify which types of bacteria play a role in recovery and target specific bacteria that may be beneficial to use as a therapy in bettering outcomes, so that with a simple swig of a pill, ingesting thousands of good bacteria as a probiotic may help to reduce inflammation in the gut, flourishing and balancing our delicate intestinal ecosystem, allowing for our gut bacteria to keep the gates between our intestinal cells closed, reducing inflammation in the brain, and potentially making a big impact in recovery from concussion, returning our gut and brain back to a happy state. Thank you.
The next presenter is Richard Lynn, who's supervised by myself and Patrick Kwan, and he is going to be talking about targeting epilepsy in Alzheimer's disease. Go ahead, Richard.
Very nice.
Imagine losing your memory bit by bit every day. Many of you might think about things such as forgetting about people's names, your favorite food, favorite restaurant, but it's not just that. The people you love will even become strangers to you because you can't remember their faces, their voices, or the moments that make you love them. Or even worse, you can no longer be who you were because of forgetting those precious memories or events that shape your personality that you have today. It's a horrible life to imagine. But that's the reality of those who live with Alzheimer's disease, or AD. AD is exactly the kind of disease that will take away your memory, among many other things. This disease has become the leading cause of death in Australia. This disease costs Australia $15 billion per year. So far, because we still don't know the exact cause of AD, there is no cure. If you use a microscope to look into this patient's brain, you will find that in regions responsible for memory forming, the neurons are dying. And those survived are losing connections with each other, which eventually cause the loss of memory. Due to the many factors at play, it's very difficult to target all of them. So the research in our group focused on one aspect related to AD, epilepsy. Why? Not just because AD patients are more likely to develop epilepsy, but also because after each onset of epileptic seizure, the memory of AD patients get worse, just like these trees on fire. So in my study, I looked a little bit closer into what really happened in this using an animal model of AD. We have found that there's one particular GSK3 pathway plays a very major role in maintaining neuronal structures. So we tried to induce seizure in these animals, and what we saw is a disturbance of this pathway, which has been proved will eventually cause the collapse of neuronal structure and eventually neuronal death, which can ultimately accelerate the loss of memory. So maybe by controlling epilepsy and regulating this particular pathway, we can slow down the progress of AD.
Hi.
Now, I want you to think about your happy memories and what are you willing to trade to keep these memories? Because after getting 65 years old, 1 in 10
You're
people
not allowed to hug her because you're sick and I want to hug her.
might not be able to retain your memory if nothing is done about this disease. So I hope my research can help you keep your memory a little bit longer. Thank you.
Next speaker is Nicola Sergenko. She is supervised by Kate Weeks, Julie McMahon, and Daniel Donner. And the title of her presentation is Shedding Light on Cardiac Protein Phosphatases, the Role of B55A in Heart Development and Disease. And your time starts now.
Okay, so today I've got a real underdog tale for you all. To begin, I'm going to introduce you to the two key players in this story. And both players are equally essential. They're critical even for regulating thousands of cellular processes inside the heart. And they can do this because they're both enzymes, proteins with highly specific, targeted functions, which enable them to regulate the activity of other proteins inside the cell. And how these two enzymes regulate the activity of other proteins is really simple. One enzyme attaches a tag known as a phosphate group in a process called phosphorylation, and the other enzyme removes it. And phosphorylation is an extremely important process. 90% of all proteins are capable of undergoing phosphorylation. And right now, at this very moment, 1/3 of all of the proteins inside your body are phosphorylated. Phosphorylation is particularly important in the heart as it enables cardiac function to be regulated quickly and efficiently in response to changing conditions in the body. For example, phosphorylation of key heart muscle proteins can alter the speed and strength with which your heart is contracting in an instant. So when your heart starts to race because the cute barista smiles at you, or you suddenly realize that you're closer to the end of your PhD than you are to the start, that's phosphorylation. So I'll put you all out of your misery. The two enzymes that I'm alluding to are protein kinases and protein phosphatases. They're the yin and yang, or the Beyonce and Jay-Z of protein phosphorylation. Unfortunately, one half of this phosphorylation power couple has been left to languish in the dark. While protein kinases bask in the spotlight, researchers dismiss protein phosphatases as promiscuous, as less interesting than kinases, as a nuisance, and even as ugly ducklings. And yeah, these are quotes from actual peer-reviewed scientific publications. And because of this grave miscalculation by scientists around the world, protein phosphatases are understudied, particularly in the heart. But we are learning, and it has become clear in recent years that protein phosphatases are important players in disease development and represent therapeutic targets. So for my PhD project, I'm putting the spotlight on one specific phosphatase called B55 alpha. And we have some exciting evidence from studies undertaken in cells that this enzyme could be protecting the heart during stress. And unsurprisingly, very little is known about this phosphatase in the heart. So I'm going to dive in further to find out what this enzyme is doing during heart development and what role it's playing in the healthy and diseased adult heart. So developing a deeper understanding of the role of B55 alpha will help to shed some light onto protein phosphatases, the underdogs of the enzyme world. And this will undoubtedly provide further opportunities for research and for the development of new therapies for cardiovascular disease. Thank you.
Don't blow our perfect record, please. The next speaker is Jacques Ma, supervised by Carlos Rosada and Merlin Thomas from the Department of Diabetes. And he's going to be telling us about chasing the silver bullet, a magic weight loss pill. This sounds good. All right, take it away, Jacques.
Fat and sugar. Who doesn't love that? It's a magic formula to the world domination of fast food chain empires. Think donuts, think ice cream, think burgers and fries. But it's this deadly duo that has the world's waistline growing and blood sugars rising. Forget COVID. We've been battling a pandemic against diabetes and obesity for far longer. And these are chronic, lifelong diseases with life-threatening complications we're talking about with no vaccine or cure. But what if I told you that I'm making a magic weight loss pill and that the key ingredient has been in you all along? A hormone called GLP-1 that's made by your gut every time after you eat. It tells your gut to wriggle slower so that food passes through slower and sends signals to your brain telling it you're full. It also travels directly to and activates the parts of your brain that tell you to stop eating. It takes this even a step further and goes to the organ that looks like a leaf, the pancreas, and calls out its hormone friend insulin to come out and play. And insulin's favorite thing to do is to convert sugar into energy or pack it away into your liver, muscles, and fat for use later. But if GLP-1 is so magical, then why are 2 in 5 adults overweight or obese? Why is diabetes killing 1.5 million people each year? Over time, with repeated indulgences in that deadly, decadent duo of fat and sugar, our body's communication system crashes. With dodgy reception, GLP-1 can't call up your cells in the gut and brain and tell them, you're full now, stop eating. And it can't get through to its hormone friend insulin and tell it, come on out, help clean up the sugar, please. So how does it get the message across? Well, if you can't call them up, then you go straight to where they live and you talk to them directly. GLP-1 can't normally do that. Cells have toll booths set up all along their borders, stopping things from getting in, and you need special access to get through. So remember how I said that GLP-1 was only the key ingredient in my magic weight loss pill? The other ingredient is a cell-penetrating peptide, or CPP, which is basically a truck you can load GLP-1 on as cargo. And the best feature is that it has a built-in e-tag that lets us zip straight through the toll booths and into the cells with GLP-1. So there you have it, the not-so-secret formula to my magic weight loss and sugar-crushing pill that can restore GLP-1's natural ability to do its job exactly where it needs to be done. My job is to figure out how best to let it do its job and how best to load this GLP-1 on so that it can go in without getting degraded and chewed up by enzymes normally in our blood, and even tack on a GPS so we can direct exactly where we want it to go inside the cell. With my magic weight loss pill, your body's going to know when to stop reaching for that extra chip or cookie or donut, and it's going to be effortless for you to do so. Fat and sugar, bring it on.
Georgia Simons from the Department of Neuroscience, supervised by Sandy Schultz, Megan Clough, Scott Colby and Joanne Fielding. The title of Georgia's presentation, Hitting Close to Home, Concussion in Australian Rules Football. Take it away, Georgia.
This is Iron Mike, a former American football player for the Pittsburgh Steelers. He got this nickname for his toughness to play through injuries. However, in retirement, the cracks began to show. He started to exhibit strange behaviours, like disappearing for weeks on end without explanation, sleeping at train stations, and even using a taser to shock himself unconscious just to get some sleep. In 2002, Mike died at the age of 50. Making his mark both in life and death, Mike was the first ever American football player to be diagnosed with chronic traumatic encephalopathy, or CTE. CTE is a degenerative brain condition linked to repeated concussions, and this discovery shocked the sporting community. It was once thought that this concussion problem was not an issue here in Australia, but this is recently starting to hit close to home. As last year, for the first time ever, CTE was discovered in an Australian footballer, the late Polly Farmer. With over 1.5 million people participating in Australian football, this issue is of high importance here at home. Concussion is a mild form of brain trauma, but just like smoking one cigarette won't kill you, the long-term effects of concussion are linked to repeated knocks to the head. Footballers are known to sustain multiple knocks in one game, times that by their whole career, and these potential damages start to add up. At the moment, diagnosing concussion relies on us subjectively reporting our symptoms. However, we know that this does not accurately represent what's going on in the brain, and players are often dishonest with their symptoms and put themselves at risk of further damage. My research looks at biomarkers of concussion. Biomarkers are measurable characteristics that tell us more about what's happening in the brain and can't be cheated. An example of this is how we use BMI to look for risk of obesity. One of the biomarkers I'm investigating is telomere length. Telomeres are the little bit of DNA at the end of your chromosome that protects your DNA from damage. It's kind of like the plastic bit at the end of your shoelace. So far in my research, we've found that footballers have shorter telomeres than people that have never played contact sports, and we think this might be due to damage from concussion. We hope to use these biomarkers to aid diagnosis, monitor recovery, and ultimately protect athletes from these long-term consequences, such as CTE that Iron Mike suffered. Biomarkers are crucial to hit this concussion problem on the head. Thank you.
Next up is Rachna Ram, supervised by Warren Rosen, Paul Bonington and David Hunter-Smith. And the title of Rachna's talk is Application of CTA and Augmented Reality for Deep Inferior Epigastric Artery Flap. The floor is yours, Rachna. 3 minutes starts now.
Thank you. A computed tomography or CAT scan is one of the most valuable information that you can give to your surgeon prior to surgery. It is the digital window into your anatomy, and it involves taking hundreds of very small snapshots or slices of a part of your body. When the slices are oriented in the right order, they form a stack of gray, white, and black shaded data, which form a volume. The surgeon can scroll through this to make meaningful decisions and plan your surgery. Now, what if we could use this data to create an actual digital window into you or get X-ray vision? What if we could use this information to see through the skin on you? Every year, thousands of women in Australia and around the globe are diagnosed with breast cancer, and some will sadly lose their breasts to this terrible disease. Some will go on to be eligible for breast reconstruction, and a popular method is to use the lower abdominal tissue based on very small blood vessels, and this is then connected to small blood vessels in the chest to make a new breast. You would be surprised to know that this very highly technical and delicate surgery used to take 8 to 10 hours, but with the information provided by CT scan, it can now take up to 4 to 5 hours. My research involves working in a collaborative team of computer visualization scientists and reconstructive surgeons to apply computer vision to extract high quality, clinically relevant, and meaningful specific anatomy of the blood supply to the lower abdominal skin and tissue. This digitally extracted information can then be rendered in 3D and then can be converted into holograms. Using augmented reality glasses, we can then anchor this digital or holographic version of you onto the real you in the operating theater, and this is known as mixed reality. We can also use the same models to create your own personalized 3D printed anatomy for information, understanding, and even training purposes. This could free up the surgeon to then focus on other aspects of improving outcomes in this surgery, such as improving their operating time, aesthetic outcomes, and precision. So in conclusion, augmented reality glasses and technology is here, and we cannot wait to see what it could offer clinicians and patients. Thank you.
Okay, next up is Mohammed Javed. He's supervised by Anna Antonick Baker, Alison Anderson, Terence O'Brien, and Patrick Kwan. And his thesis presentation is going to be on development of personalised disease in a dish model of epilepsy using stem cells. Take it away, please.
Epilepsy is a complex neurological disorder that is characterized by recurrent unprovoked seizures, and it affects almost 70 million people worldwide. Although multiple drugs are available to treat epilepsy and seizures, but still 30 to 40% patients are drug resistant. And surgery may be the only treatment option for these drug resistant patients. As I mentioned, epilepsy is a complex disorder, so it is hard for the surgery to be used alone for complete seizure freedom. And almost 40% of patients experience seizures even after surgery. So to address this problem and to find an answer, we need improved disease models. Animals are useful to model different diseases, but it is a long-standing challenge for the researcher to model complex neurological diseases like epilepsy, because animal models do not mimic the exact pathogenic mechanism of human disease. So we need human-based disease models. Now the question is, can we use human as a disease model? No, we cannot, but we can use their blood. And that's what we did in the lab. So we isolated cells from patient blood and converted these cells into stem cells. Stem cells are the cells that have ability to make any type of cells of the human body. So using these patient-specific stem cells, we converted them into neurons, and when studied, these patient-specific neurons show different behavior and electrical activity compared to the normal neurons, which is an indication of the successful development of personalized disease in a dish model. This personalized disease in a dish model can be used to study and investigate the pathogenic and drug-resistant mechanism of epilepsy, and can also be used to screen the potential drug candidates in order to make effective medicines to treat epilepsy and seizures. So the conclusion is that human stem cell-based patient-specific disease in a dish model can be used to study and to find a treatment for the complex diseases like epilepsy. Thank you.
Okay, and our final speaker today is Erskine Chu. Erskine is supervised by Bridget Semple, Margaret Hibbs, and Rochelle McChaswick. And the title of his presentation is How SHIP1 Navigates the Injured Brain Through the Course of Recovery. And your time starts now. Go.
Hello, ladies and gentlemen. Today, I'm going to tell you a story, the story of Humpty Dumpty. One day, little Humpty Dumpty was sitting on a wall, and suddenly he had a great fall. He landed on his head, his shell cracked, and his brain was severely injured. But luckily, the town folks were able to put Humpty Dumpty back together. But then, when Humpty Dumpty got older, he started having trouble learning and remembering things. And on top of that, he was depressed and anxious all the time. So, he decided to come to us to see what's going on. And after examining Humpty Dumpty, we found that there was a change in the amount of a molecule called SHIP1 within him. It's very important in controlling and managing the immune system, but its function in the brain is still unclear. So, to address this, we went back to our lab and created mice that specifically don't have SHIP1 to try to figure out what it does after brain injury. So, we divided our normal mice and mice without SHIP1 into two groups. One group of mice received a single injury to the brain to mimic Humpty Dumpty's fall, and the other group of mice received no injuries at all. And afterwards, we noticed that those mice without SHIP1 appeared to be more docile and sicklier after the injury compared to all the other mice. And upon closer inspection of their brain, we noticed that these mice sustained a greater amount of brain damage. And lastly, we decided to compare their immune responses and found that the brain immune cell, microglia, in mice without SHIP1 produced a much greater immune response following the injury compared to the normal mice. So, based on these observations, we believe that SHIP1 is a key molecule in stopping the brain immune system from overreacting after injury and causing further damages in the developing brain. And with this information, perhaps there's a way that we can use SHIP1 to fix Humpty Dumpty once and for all. Thank you.